Bonsuelo, everybody. Okay, we're going to go back and talk about exponential equations, which we've already done before. But this is what we're going to talk about. Okay, remember when we had like 2 to the x power equals 16, let's say. Okay, that's an exponential equation. Why? Because where's the variable? It's in the exponent. What do? We get the bases the same, and then you just say x is 4. Fine. Okay, but what if this happens? You say 2 to the x equals 5, and you can't get the bases the same. That's what we're going to talk about today, okay? What do you do with an exponential equation that you can't get the bases the same? But remember, you always want to try and do that first. Okay, couple preliminary ideas. Remember, this is a log equation. We're not dealing with that today, okay? This is what we're going to end up dealing with today, and this is not a log equation. It's a linear equation. Why? Because we're not taking the log of the variable, right? It's just an x. All right. Next, remember, you can't distribute the operation log, but you may distribute like the log of 7 because that represents a number. Okay? Third, remember the third log rule allows you to move a value from an exponent to in front of the log. Now, this is expanding using the log rules. And remember I said for the most part you don't want to expand using the log rules, but today we're going to need to. Okay? So what mathematical operation is going to allow me to take a quantity out of the exponent and put it in front of the log, the third log rule? Okay? So the only math operation that allows you to take a variable out of an exponent is the third log rule. And I want to remind you of something. When we did this before, 2 to the x equals 16. So 2 to the x equals 2 to the 4th. And so x equals 4. How did we know x equaled 4? By common sense. We did not perform any mathematical operation. But what we're going to do today, where we have something like this, we are going to have to use a mathematical operation because I can't get the bases the same. Okay? All right. So, for instance, okay, 2 more things. Do you always need to use the third log rule to get something out of the exponent? No. Okay? In the sense that, remember, you want to try and simplify the log first. So what's the base in this problem right here? What's the base? E. Not because this is an E, but because the natural log means log base E. Well, how do you simplify a log? You get the bases the same and tell me the exponent. So the natural log of e to the x plus 3 power is just x plus 3. It's like saying this. If I had the natural log of e to the 4th power, the answer would just be 4. Why? Because the bases are the same, so you tell me the exponent. Well, how about if I said this? The natural log of 4 plus x. Okay, the exponent's 4 plus x. So, because the bases are still the same. So, the natural log of e to the x plus 3 power is just x plus 3. We don't need, the natural log of e after it. We're not using the third log rule here. Same thing with this one right here. Okay? The base is 10. Why? Because that says nothing, so it's understood to be 10. But since this base is 10, therefore, it's just 4x. Because the bases are the same, so you just tell me the exponent. Okay? So you need to keep all of those things in mind. Now let's take a look at some problems. Okay, I want to remind you, we've already solved exponential equations by getting the bases the same. Here's a simple, well, not a simple example, but there's an example. But what do you do if you can't get the bases the same? For instance, 3 to the x equals 7. Okay, the main idea is use the third log rule. But take a look at this problem. We can't use the third log rule. Why not? There are no logs. There have to be logs in the problem to use the third log rule. So somehow we have to introduce a log. Now, okay? First, we're going to take the log. We're not going to log it. We're not going to multiply by the word log. You can't multiply by a mathematical operation. It's kind of like saying this. If you have x cubed equals 8, what do? You can take the cube root of both sides and get x equals 2, okay? When you perform an operation, a lot of times it's expressed in a way, you take that operation, okay? Now, why are we going to use log base 10 or log base e? Because those are the ones on your calculator. So what are we going to do? We're going to take the log of both sides of the equation, right? We're not multiplying by the word log or logging it, okay? All right, now it's a log equation, okay? So we can use the third, because the variable's in a quantity that we're taking the log of. So we use the third log rule, and we take this variable and put it in front, okay? Giving us step 2. All right, now this is no longer a log equation because I've taken the variable outside of the log. What is it? It's a linear equation. So you just, if you had x times a number equals another number, you would divide by that. So we're going to divide by this thing, both sides by this. And we get that. Okay, and then you use your calculator. And this is called calculator ready form. I may ask you to just get it in calculator ready form and then leave it, in which case you just leave that if I want you to actually, or Alex may ask it also. And then if you have to actually give a decimal, then you just plug it into your calculator. Okay, so let's just take a look at some examples. Okay. Oh, and I just want to point out, notice if you used a natural log instead of a common log, okay, you end up with the exact same answer. That's all I'm saying there. Okay. In this problem, it doesn't matter whether you use a natural log or a common log because the base is 3. Now, but if your base is 10 or your base is e, then it matters. If it's a log base 10, you want to use common log, log base 10. If it's got a base of e, the exponential function has a base of e. I forgot to put the 7 in there. I just realized that. So I'll correct that by the time I pass out the paper, but I didn't want to do that. I don't know exactly what I'm doing here. Let's go back to... Okay, I don't know how that happened. Anyway, okay, this should have been what the problem is. E to the x equals 7. Then you take the natural log of both sides, okay? So, again, on the paper that I'll have Xeroxed by the time, I pass this out to you, it'll be corrected. It'll have the 7 on there. Okay, so let's take a look at some examples. Okay, so let's first of all, we can't get the base the same, so I'm going to take the log of both sides. Okay, and then I'm going to take this quantity and move it down in front of the log. So we have x plus 5 log of 17 equals log of 31. And this is wrong. Be very careful. It's not x plus 5 times the log of 17. It's the quantity x plus 5, that quantity times the log of 17. Okay? And now it's just, how do you get rid of the log of 17? You divide it. Okay, then you subtract the 5. Okay, and then at that point you'd use your calculator and just finish it off. Okay, if you're required to use the calculator. All right, in class we'll go through the calculator. Okay, in this case, don't take the log of both sides. Take a look at it. We can get both of these bases to be the same thing. This will be 2 to the third raised to the 5x plus 4 and this is 2 to the negative first, which is 2 to the 15x plus 12 equals 2 to the negative first. And then by common sense, 15x plus 12 equals negative 1. And x equals negative 13/15. Okay? So remember, you only do what I did on problem number 1 if you can't get the bases the same. All right? All right, let's take a look at this one. I can't get the bases the same, so I'm going to take the log of both sides. Okay, so I'm going to take the 0.56 and move it in front. Now, I can get rid of the 0.56 and the log of 8 at the same time because they're both multiplied by x. So I'm going to divide by the 0.56 and the log of 8 at the same time. And then that's calculator ready form. Okay, here what do we want to do? Well, you're going to take the natural log of both sides. Why? Because it's got an e. And what's the natural log of 13x? Natural log of e to the 13x power is just 13x because the base is the same, so you tell me the exponent, and that's equal to the natural log of 56, and then I just divide by 13. Okay, now let's go back. And that, again, that's calculator ready form. Let's go back and just do this on the calculator. So I'm going to take the log of 31, divide by the log of 17, sum it up, and then subtract 5. And you should get approximately 3.78 795, blah, blah, blah. And, what you round off to just depends on what Alex asks or what I ask for. Okay, in this case, remember, whenever you have a bunch of stuff in the numerator or denominator, more than one thing, you've got to put parentheses around the numerator and denominator. So here, I'm going to put parentheses around the log of 13 and then divide by the whole bottom, okay? So I'm going to open parentheses and take the log of 13, and then I'm going to close parentheses. Then I'm going to divide by, open parentheses, and I'm going to put the log of 8 in first. It'll be easier. 8 times 8, the log of 8, times 0.56. Then close the parentheses, and then sum it up, and you get 2.20, 26, blah, blah, et cetera, et cetera. Okay? On this last one, you get the natural log, and it has to be a natural log because that's what we used, the natural log of 56 divided by 13, and that gives you 0.3096, et cetera. Okay? And so remember, you have to make sure you're using a natural log, okay? And obviously on problem 2 here, you don't use the calculator at all because we didn't need logs at all, okay? Just going to run through and check the answers again to make sure I didn't make a mistake someplace. So I've checked 3 and 4. They're good. Okay, let's try. And that one's good. So they're all good. I didn't make a mistake on the calculator. Okay, this is a more complicated problem. All right? Because we have an exponent in a variable in each exponent. So again, I can't get the bases the same, so I'm going to take the log of both sides. So we have not x plus 5, but the quantity x plus 5 times the log of 7. And that'll be equal to 3x times the log of 4. Okay, now here's the difficulty. Notice we have x's on each side. Okay, now I'm going to compare this to something. So just listen. Don't write any of this down. Just listen. Remember, this is a linear equation. Well, what if you had this? What if you had, I don't know, I'll just make up something. 8 times x plus 3 equals 5x. What would you do? You'd first of all distribute the 8. You'd get the x's on one side and the numbers on the other side. And then you would divide by -3. Okay? All right. We're going to do the same thing here. What did we do? We distributed the 8. We got the x's on one side, the numbers on the other side. And then I just got x by itself. Okay. So, what am I going to do? I'm going to distribute the log of 7. Now remember, you can't distribute the word log, but I'm not distributing the word log. I'm distributing the log of 7, which represents a number. So I'm going to take that and give it to each one. And what we get is x log of 7 plus 5 log of 7 equals 3x log of 4. All right. Now, what do we do after that? Get all the x's on one side, all the non-x's on the other side. So we'll leave the 5 log 7 here and subtract the x log 7. So we get 3x log of 4 minus x log of 7. Now, here's where the difficulty comes in. Let me go back to this example I had before, or similar one. I can't remember exactly what I had. But let's say we had this. And I'm just making up a different one. Okay, so we distributed the 8. We got the x's on one side, but notice when I took 5x minus 8x, that gave me -3x. Why? Because I could combine the 5x and the 3x. These we can't combine. So here's the difficulty of this problem. You want to get it so that there's only one x. But right now we've got 2. So what can I do? Well, here's the idea. I'll just write this first. How can I rewrite this with only a single 2? Well, I can factor out a 2, and you don't need to write this down. Okay, how about if I had this? xk plus xz. How could I rewrite that with only a single z? I can factor out an x. Sorry, not with a single z. With a single x, let me go back up a little bit. How can I rewrite this thing with only a single x? Okay? What I can do is factor out an x. Okay? So what am I going to do? To this problem that we've got here, I've got 2 x's, but I only want 1 x, so I'm going to factor out an x. And if I take an x out of each one, I end up with 3 log of 4 minus log of 7. Now, I can divide by what's being multiplied by the x. So it's 5 log 7 divided by 3 log 4, minus log of 7. Okay, that is calculator ready form. And now, when you plug this into your calculator, what do you need to do? Put parentheses around the top and put parentheses around the bottom. Okay, but that's calculator ready form right now. Okay, so let's put this in the calculator, and I'll do it twice to check myself. First of all, open parentheses. And I'm going to take the log of 7 first, and then multiply by 5, and then close parentheses. Okay, so that's the top. Then divided by, open parentheses again. Okay, and I'm going to take the log of 4 times 3, okay, minus the log of 7, and then close parentheses, and now push equals, and you should get 4.39, and I'm going to round this off to 4 decimal places, 66. Okay? It's actually 4.396597, et cetera, but if you round off to 4 decimal places, the 5 rounds up to a 6. Okay, I'm just going to run through that again on my own real quickly just to make sure I didn't make a mistake, but yep, we're good. Okay, it's a fun problem. So that's it. Hopefully that was helpful to you. Have a good day, everybody.